So what I'm going to do here is I'm going to run a multiple regression, and the one that I do actually aligns with the reporting regression Word document, so that should be helpful. So this data set here, we've got final university grade, which we are trying to predict, and we're trying to predict it with three predictors: entrance exam, project score, and IQ. So we're in SPSS, so in order to run the analysis, we click on Analyze, go down the menu to Regression, and on the Regression menu go down to Linear. And in the dialog box, we take our predicted variable, final exam, and we put it in the dependent box, and then we take our three predictors and put them in the independent box. Then there's a few things that we have to ask for, so click on the Statistics button, and we ask for part and partial correlations and collinearity diagnostics. Click on Continue and click on OK. And we get the output window appear. So what do we get in the output window? Well, first of all, we've got this variables entered remove box, which we can pretty well ignore. It just shows us which predictors and predicted variables we've got in there. In the model summary box, the most important value that we have in here is the value of R squared. This is the proportion of the variance in the final exam marks that can be explained by changes in our three predictors. So 0.776 is a very high value. It indicates that 77.6% of all the variance in the final exams can be explained by changes in our predictor variables. The adjusted R square, we wouldn't need to report that, but it's just a slightly low value. That's adjusted in terms of the number of predictors we have and the number in our sample. The standard error of estimate, 16.229, you might want to report. It's the average amount by which a predicted value will actually differ from the real value in the data set. So 16 is quite a reasonably large number, given that we're explaining quite a lot of the variance. The next table we have is the Anova summary table. The Anova summary table is a significance test to see whether the R squared value that we've got is actually significantly different to 0. And as you can see in the SIG box here, we've got 0.000, which indicates that the test is significant at less than 0.001. You report this by saying that R square of 0.776, the regression is significant. F with 3 and 29 degrees of freedom equals 33.463, p less than 0.001. So the regression is significant, it's good. We can therefore move on to our coefficients table. Now the coefficients table looks at each of the predictors in turn. Okay? And what we have, and the things that we're really interested in here, are the standard coefficients beta, where higher values show a stronger contribution to the regression. And these are tested with t-tests, and we have significant values for each one. So if we look at these, they're all significant. All of them are making a significant contribution. The weakest contribution is for the project score, but this is still significant at p equals 0.023. To report these, you would report, if we take an entrance exam, we would say that entrance exam is making a significant individual contribution to the prediction. Beta equals 0.512. T, and the degrees of freedom for the t-test are 29 there. So t with 29 degrees of freedom equals 5.272, p less than 0.001. And you repeat that process for the other two as well. So the degrees of freedom for all these three t-tests are 29 here, the degrees of freedom for the residual from the Anova. What else do we get in this table? Well, we get correlations, zero order partial and part correlations. As you can see, that as you move from zero order to partial to part, these decline in size. And this is because the partial and the part correlations remove shared variance with the other predictors. But even when they are reduced, they're still making a significant contribution. The collinearity statistics, you ought to comment on the collinearity statistics. And here for the VIF values, we want values near to 1 to indicate there's no problems. These are all very near to 1. If they're higher than 5, it might be indicative of a problem. If they're higher than 10, certainly indicative that there could be a problem. What this means is that the predictors would be overlapping with one another too much, but they're not doing. These statistics are absolutely fine. Okay, so we've got our beta values, we've got our test of significance, we've got our collinearity statistics. If you wanted to, it's possible to actually calculate the confidence intervals for these beta coefficients. But if you want to do that, the first thing that you have to do is get SPSS to save the predictors and the predicted variable as z-scores. And in order to do this, click on Analyze, down to Descriptive Statistics and over to Descriptives. Place our 4 variables, the predicted and the predictors, into the variables box and check this Save Standardized Values as Variables button. And click on OK. Now, if I just go back to the spreadsheet, you'll see that we've now got Z-Fan, Z-Pro, Z-IQ. These are Z-scores for all the different values. If we now repeat the regression, analyze, regression, linear, reset that and put in Z-score finally, examine the dependent box, and Z-score for the 3 predictors. Like that. And then click on Statistics. And if we ask for confidence intervals now, the level is set at 95, so 95% confidence intervals. If we click on Continue and OK, we get the analysis done again, and we just want to go straight down to the coefficients table. Now the thing that's changed here, you see, is that by using Z-scores, we have now got exactly the same unstandardized. Oh, I forgot to select the. No, I did select the confidence intervals. They're here. So you've got the same values for B, the unstandardized coefficients, as you have for beta, whereas they were different previously. Now then, what this means is that these confidence intervals that we've got at the end here are the confidence intervals for the standardized beta coefficients. So for this one, where the coefficient beta is 0.512, the 95% confidence interval is 0.313 to 0.710. So you could report the 95% confidence intervals for each of the beta coefficients as well, if you wanted to. Okay, and that is everything I think that you need to know in terms of running the multiple regression for the assignment.